All right, so looking at this, your do now is really dependent on the classroom composition of your room. However, we'll just go ahead and make some stuff up for the sake of this lesson. Let's say there are 10 girls and 20 boys in the classroom. You should be able to determine the total number of students in the classroom is 30. Percent of the number of students that are girls. So this is our quantity is equal to percent times whole. This is 10 out of 30. So that's going to be 33.3 repeating percent are girls. And that's going to leave me with 66.6% are that. And so of boys and girls, that makes up 100% of the class. Number of girls whose names start with a vowel. That's A-E-I-O-U. So let's say there are 5. And say there are 3 boys. Number of students whose names start with a vowel. That's a total of 8. Percent of girls, so this is 5 out of the number of girls, that's 5 out of 10, which is half or 50%. Percent of the number of boys, that's 3 out of the 20 boys, which is going to be 15%. Percent of the total number of students that are girls whose names start with a vowel. Okay, so girls who start with a vowel, that's 5. Of the total number of students is 30. 5 out of 30, that's going to be 16.6 repeating percent. Percent of the total of students who are boys that start with a vowel, so that's 3 boys that start with a vowel. The total number of students is 30, is going to be 1/10 or 10%. And percent of students whose names start with a vowel. So this is going to be the total number of students who start with a vowel. That's 8 out of the total number of students out of 30, which gives us 26.6 repeating percent. All right, let's flip on over and look at our aim for today. All right, today's aim, Kipsters will be able to solve multi-step percent problems. Multiple step percent problems. So really today's work is all about just getting everything set up and diagrammed. I think that's 90% of the battle. So we say that a school has 60% girls and 40% boys. If 20% of the girls wear glasses and 40% of the boys wear glasses, what is the percent of students that wear glasses? So thinking about setting this one up. So we're starting with our entire school. And we are saying 60% and 40%. We're splitting it up into 60% is girls and 40% is boys. And of those girls, 20% wear glasses. So this is girls with glasses. And this over here is boys with glasses. And there are 40% of the boys that wear glasses. So what percent of all students wear glasses? So what we would need to figure out is how many of these girls wear glasses, how many of these boys wear glasses, and then we need to make that a percent. So we need to add these two things to get some number down here is the total. and we need to figure out what percent that is of the entire school. We're looking at what percent of the school is that? Question mark. All right, so looking at this, 60% of the girls, we don't have values here, so let's pick a value. As we've learned, 100% is a nice little value to work with. 100 students is a nice little value to work with. So 100 times 60%, so we're thinking about this is Q is equal to percent times whole, 60%, so 0.6 times 100. That's going to tell me there are 60 girls. Q is equal to percent times whole. That's 0.4 times 100. There are 40 boys. Of those 60 girls, 20% of them wear glasses, so Q is equal to percent times whole is 0.2 times the whole now is 60. And it's going to tell me there are 12 girls who wear glasses, so this is 12. Over here with the boys, Q is equal to percent times whole, 0.4 times there are 40 boys. That tells me there are 16 boys who wear glasses. That's a total of 28 students who wear glasses. So our school is our whole, so if we're thinking about setting this one up, Q is equal to percent times whole. Our whole is the whole school, that's 100, and the part is 28 students with glasses. So we solve that, we're going to get our percent is equal to 20.28 or 28%. So as you can see, really this is about getting it set up and thinking through everything that's happened. All right, so how does the percent of students who wear glasses change if the percent of girls and boys remains the same? That is 60% and 40% boys, but 20% of the boys wear glasses and 40%. So thinking through our diagram, again, we're starting here with the whole school. We're still splitting boys and girls the same way we did before. So 60% is our girls, and 40% is our boys. And of our girls, now we're saying 40% wear glasses, and of our boys, 20% wear glasses. So we have girls with glasses, boys with glasses, and we need to find the total number of students with glasses in this particular problem. And again, looking for that as a percent of the school. So this is not going to change. This is still going to be 40 boys and 60 girls. But because our percentages change here, Q is equal to percent times whole. This is going to be 0.4 times 60, which will give me 24 girls with glasses. And our boys, Q is equal to percent times whole. It's going to be equal to 0.2 times our whole is 40. Tells me there's going to be 8 boys with glasses. So we end up with 32 in total, which again, since our school started at 100, Q is equal to percent times whole. Our part is our 32, our whole is our 100. That makes our percent to be 32%. So we can see that it increased, and it makes me wonder why, because all of the numbers are the same. Well, our percentage, when we're thinking about, there's a larger percentage of the girls, which is a larger amount. So as a result, the increase in the amount of girls is probably worth more than the increase in the decrease in the amount of boys. So that's the way that we can kind of think about that. So coming over here, we want to do the same thing. Now we're actually switching up the composition of our school in terms of boys and girls, so we've got to start from scratch. So go ahead and see if you can't set up and do this problem on your own. So jumping through this, we're still starting with our whole school. And we've now got 40% is girls. We've got 60% is boys. And our girls, it's 40% and 20%. So we're going to find our number of girls with glasses and our number of boys with glasses. Starting again with the school of 100, that would tell me that there are 60 boys and now 40 girls, so this is different than it was before. Percent times whole, this is going to give me 16 girls with glasses, and this is going to give me 12 boys with glasses, and this gives me a total of 28, which, going back, that's 28 out of our 100, which is 28%. So we can see that this answer matches our previous answer from the very first problem, and that's because we see the same setup here. We see we're going from 60% to 20%, 60% to 20%, 40% to 40%, 40% to 40%. So we see those things align. That tells us that the values are going to be the same. Now it's just switched. Which has the 16 and which is the 12, but since our problem is really just talking about the total, we still end up with the same thing. Alright, so looking at the next one, it says the weight of 3 containers. Alright, so I'm going to start with 3 containers. I'm just going to call them, since they're labeled here, this is going to be my first, this will be my second, this will be my third. The first of 3 containers is 12% more than the second. So we have to be careful with this one. It's not 12% of the second, it's 12% more. So the first container is 112% of the second one. So it's 112% of the second one, 112%. And the third container is 20% lighter than the second one. So it's 20% lighter. It's not 20% of it, it's 20% lighter than the second one. So it's 80% of the second one. And so now this actually looks like some of the problems we had before. It says, by what percent is the first container heavier than the third container? So when we look at this, we're going to say, pick a value. This is 100. So Q equals percent times whole. That's going to give me, this one is 112. And this one is going to be 80. And we want to know what percent the first container is heavier than the third container. Okay, so we're comparing percent first container than the third container, heavier. So what we're trying to do is we're trying to take the third container and compare it. When we think about this, this is going to be our original. So Q is equal to percent times whole. Our original here is our 80 going to 112. We want to know what that percent is. Divided by 80, divided by 80. That tells us our percent is equal to 140%. And so we have to be really careful with this question. It says, by what percent is the first container heavier? So it's not 140% heavier. It is 140% of the original container. So how much heavier is it? Well, that's the extra 40%. So there's an extra 40%. And that's the actual answer to this question. However, I mean, obviously, if you've gotten this far, you've gotten pretty close. All right, so this problem is very much like the previous problem. See if you can't go ahead and set it up on your own. Set up the diagram and then check in to make sure your diagram's correct. And then once we've checked your diagram, then you can go ahead and solve it on your own. So thinking about this diagram, we have Matthew's dog, we have Harrison's dog, and we have Janice's dog. So I'm just going to set up some space for all of that. All right, this will be Matthew, Harrison, and Janice's dog. Matthew's dog is 7% heavier than Harrison's dog. So Harrison's dog, it's going to be 107%. Janice's dog is 20% lighter than Harrison's dog, so it's 20%. It's 80% of Harrison's dog. By what percent is Matthew's dog heavier than Janice's dog? Heavier than. So that's going to go ahead and make this my whole. So we're going from Janice to here, and we see that it's asking how much heavier. So when we do get that percentage, we have to be pretty careful. So looking at this, it looks like we want to go ahead and make Harrison 100 and move from there. So go ahead and now finish up this problem if you haven't done so already. So using Q is equal to percent times whole, again that's 0.8 times 100. This is going to give me 80. This is going to give me 107. Oops, 107. So now looking at this one, to figure out what this percentage is, Q is equal to percent times whole. We're going to go with our whole. That's what we started with. It's always the original, 80 to 107. And when we calculate that out, we'll get our percentage is 1.3375 or 133.75% of the original. So what that means is how much heavier is it? It is 33.75%, an extra 33.75%. All right, in 1 year's time, 20% of the investment. Okay, so it looks like we've got an investment broken down into three different parts. We've got the 20%, we've got the 30%, and we've got the 50%. So if we're thinking about setting up this diagram, we're going to start with a total. And we're going to break it down into three parts. This is the 20%, 30%, and 50%. And each of those investments changed somehow. Okay, so they became something. And we want to know by what percent did the total of her investment increase. So whatever I get for these values after the change, I need to find out the total, and that's going to be a percent of this. All right, so this 20%, we're told increased by 5%, so it's going to be 105%. The 50% or the 30% decreased by 5%, so it's going to be 95%. And the 50% increased by 3%, so it's going to be 103%. So we need to pick a starting value. 100 seems to make sense to me. Q equals percent times whole. That's going to make this 20, this 30, and this 50. So now Q is equal to percent times whole for this one. It's going to be 1.05 times 20. Q is equal to percent times whole for this one. It's going to be 0.95 times 30. Q is equal to percent times whole is 1.03 times 50. So we should get for this one, up here we get $21. For this one in the middle, the 30%, we get $28.50. And for the one on the bottom, we get $51.50. And so when we total that all up, we can see that we are actually going to end up with $101. So Q is equal to percent times whole. So our original was the 100. So this is going to be a percent of, we're 101%, which actually means we had a 1% growth. All right, and last one, we had a concert that had an audience of 6,000 members in attendance on the first night, and the same on the second night. The first night of the concert, they exceeded their expectations by 20%, and the second night they were below expectations by 20%. What was the difference in concert attendees and expected attendees as a percent of the total attendees of both nights? All right, so just thinking about this one, that's a mouthful at the end. Q is equal to percent times whole. This is our whole percent of total attendees. So this is our total attended, which we can actually already find because we know there were 6,000 each night. So this is going to be 6,000. And this is the difference in attended versus what was expected to attend. So this is going to have to be a subtraction of something. This is going to be expected minus total. And that's going to be a percent. So we have two separate nights here. And we know kind of what the difference is between the expected and the actual. So we have to figure out the expected for each of these nights. So this is night 1. This is night 2. Night 2. And this is our expected, and this is our actual. Well, we know the actuals for both of these are 6,000. 6,000. And our expected, so this is on the first concert night, they exceeded the expectations by 20%. So they were 120% of the expectation. The second night they were below expected, so they are 80% of what they expected. of their actual goal. So looking at each of these, Q is equal to percent times whole. The whole is the original, and so we actually don't know the original in this particular case. So we know the part, 6,000 is equal to 0.8 times the whole, so we divide by 0.8. That gives us that our whole, or our expected, was 75,000. So this first night they expected 75,000. The second night, Q is equal to percent times whole. Our whole, or our original amount, is the unknown. What we actually happened, our part, the 6,000, is equal to 0.8 of, oh shoot, it looks like I did these backwards. All right, so this was the work for down here. So the expected on this second night was 7,500. So this is, to do the top one, the percent was 1.2 times the whole, divided by 1.2, divided by 1.2, which means that the whole, or the expected, on the first night was 5,000. All right, so they expected a total of 7,000 plus 5,000, so they expected 12,500. And what actually happened was that we had the 6,000 plus 6,000, that is 12,000. And we're trying to find that as a percentage of the total attendance, which was 12,000. So this is 500 is equal to what percent of 12,000 divided by 12,000. And we're going to get 5 divided by 12, which is 0.416 repeating. So our percent is equal to 0.416 repeating, or that's 41.6 repeating percent. Actually, that decimal is in the wrong place. 0.0416, so 4.16 repeating percent. So that was actually a percent error problem, because we found the amount of error and we divided it by the total. All right, so that's our lesson for today. Again, it's all about being able to think through how the percentages are relating between your part and whole, and kind of setting up these diagrams to help you break things down.